Hello, I'm Brandon Doyle, and this is my second assignment for Introductory into Ammunition and Basic Ballistics. Today is June 13th, 2025. Let's get started. Today, we're going to look at some of the advancements to the modern day cartridge and what are some that made them better than just a straight walled cartridge. There were advancements from us going from a caseless powder ball and flintlock to rimfire cartridges, but our biggest leap, at least in my opinion, was the centerfire cartridge, allowing us to use smokeless propellant, and that was 3 times as powerful as black powder. But that was only the beginning of innovation in ammunition. You see, the creation of the smokeless propellant and it being 3 times as powerful, it allowed bullet makers to make some modifications to cartridges, like reducing the size of the cartridge, making bottleneck cartridges, allowing them to maximize the amount of propellant in the space, but also reducing the bullet itself, allowing it to fly further than a bullet heavier with the same amount of propellant. But that wasn't the only innovation cartridges you see to reduce the amount of friction the bullet would be restricted. They took the bottleneck and tapered it, reducing friction from the brass case to the bullet itself. That allowed them to maximize the amount of velocity and pressure that the bullet would be using to go further, because it would allow them to take that pressure that would be exponential and fly right out immediately. They also did some other modifications in terms of the 9mm. You see, they reduced the rim to some cartridges because when they're trying to do semi-automatic, cartridges with a bigger, wider rim kept catching on each other. That would cause rim lock. When they were feeding, they would just catch on each other and they would lock up the whole feeding mechanism and it would stop. And that was to combat that, they made the rimless. Now, with all the improvements on the cartridge today, there are flaws. There are variants in the thickness ever so slightly with each cartridge from here to here. Due to the amount of thickness of the case, the amount of propellant varies, and it can vary in velocity and pressure from round to round. But thanks to the Sonoran Desert Institute and their textbooks for Introductory to Ammunition and Basic Ballistics, I found out that there are some companies trying to make new cartridges. One of them can be easily produced very consistently, as well as easily recyclable. Companies like SIG with their 277 SIG Fury 150 grain hybrid Hunter are the beginning to transitioning from just brass, because such casings like this insulate the heat, the propellant, instead of conducting it and transferring it to the chamber, allowing the propellant to burn more efficiently. And now for my chosen question to answer, which is how much the surface of the chamber affects ballistic performance. And the answer is the chamber surface of a firearm can affect ballistic performance, primarily its impact on the chamber pressure and the bullet seating. A rough surface can increase friction, potentially leading to a higher pressure and velocity. Also, the chamber's geometry, especially the throat, can influence how much the bullet is seated within the case, affecting pressure and velocity. So, with that being said,